Okay, in this video we're going to take a look at solving systems by linear combinations, which is another name for the elimination method. So we need a system. So we have 4x plus 3y equals 2, and we have 2x minus y equals 6. So looking at this system, I can't just add the two equations together and cancel one of the variables. So what I'm going to do is I'm going to pick one of the equations, in this case I'm going to pick the bottom equation, multiply it by something so that the coefficients of one of the variables are equal but opposite in the two equations. So I'm going to take the bottom equation and I'm going to multiply everything I see by 3. And doing that will give me a negative 3 is the coefficient for y, which means that the 3y in the top equation and the negative 3y in the bottom equation will cancel when I add. So let's go ahead and transform that. So I'm going to multiply 3 times 2x minus y equals 3 times 6. So I'm multiplying the entire bottom equation by 3. So that gives me 6x minus 3y is 18. So now I'll rewrite the system using this new version of the bottom line. So they're the same equation, it's just scaled up by a factor of 3. But what's nice about that is this, actually, if I do add these equations together, the y's are going to cancel. And that was my objective. So here's my system. I'm going to add down. So I'll get 10x, the y's cancel, and then 2 plus 18 is 20. So I can divide both sides by 10 and get x is 2. Now what you always do is you go back to the original equations, pick one of them, it doesn't matter which. I'm going to pick the top one, and solve for y. So I'm going to replace the x with 2. So I get 4 times 2 plus 3 times y is equal to 2. 8 plus 3y is 2. 3y equals negative 6, because I'm subtracting 8 from both sides. And then y is equal to negative 2. So I know that the solution of this system is x equals 2, y equals negative 2. I could write that as an ordered pair, 2 comma negative 2. And so that's the problem, and I hope you found this helpful. Good luck.